5. Let me run this first program, logistic regression. Meanwhile, I'll explain about it. So we have used breast cancer prediction dataset, which is freely available on Kaggle datasets for this logistic regression. Let's have a look at it. It has 32 columns in total, and we are mainly concentrated on this diagnosis column, which actually predicts whether a cell is malignant or benign based on the other parameters. And we have also eliminated some of the unnecessary parameters like ID. Uh, we have tried different optimizers with the many combinations of learning rates, number of steps, and batch sizes, and we found that for this dataset, Adam optimizer better suits it with a learning rate of 0.1. So you can see that the loss has been drastically decreasing with this optimizer and the learning rate 0.1. Let's visualize this graph on tensor board. Copy the path and then just visualize it. Give that part of that graph. Okay, let's reload this. This is the loss that has been plotted on the tensor board. It's clearly visible that for each step the loss has been decreasing, and this is the main graph, tensor graph of this model. And let's go with the other one, finding the word embeddings. For this, I have used the news dataset, which is available from a third-party news website. This data has been publicly authorized and has been carefully refurbished. I have removed the punctuations and the basic uh, line numbers and stuff like that to clean the data. I've already run this because it will take a bit more time. So let's look at the embedded words here. So this is for this on trying various other optimizers with learning rates. I have found that gradient descent optimizer with a learning rate of 0.1 better suits this data set. Okay, the optimizer that I have used here is Adagrad, which is not so good. Let's see the um, visualization of it on tensor board. Okay. This is the main graph of this model, and this is the loss that has been plotted, and we can see that it's it's also decreasing from each step. So for this word to vector conversation of this particular dataset, I found that gradient descent optimizer with a learning rate of 0.1 better suits it.